Mm. Hello friends, today we are going to discuss what is cap theorem, right? So before we start, let's understand the meaning of each three characters here, right? So C stand for consistency. You might have heard this term uh, very frequently in a distributed architecture. And A stand for availability, right? And P stand for partition. And I'm appending one more word with partition is tolerance, right? So you will understand what is partition tolerance, right? So why before we start, we should know why this cap theorem is needed, right? So we all are living in a you can say era of cloud computing, right? And when the cloud computing comes, right, you the distributed computer systems terminologies come, right? The distributed means the some one computer is kept other somewhere and one computer is kept somewhere and they are talking to each other, right? So we need to ensure that how we will organize our data so that it has consistency, availability, and partition tolerance, right? So we will be working on that today, right? So I will try to understand explain you with very common example which I have read in one of the post, right, in any of the blogs. So I will try to share that. So let's suppose there is one company called ABC, right? And the job of this company is to write a reminders, right? Means, for example, if a person X calls to this company and say, please save my birth date, right, and remind me. And next day he calls back to that person, right, and he asks for the what I have saved. So I will just uh, retrieve, just give that information back to that customer, right? So this is how, and I charge very nominal amount for that, right? So this is so things are going very smooth because right now I'm operating at very small scale, right? But the problem arises when my skills uh, wider, right? Means I'm not serving more and more customers, right? I need to think means how I can cater this huge demand that I'm getting, right? So for that, lesson so let what I've done, I've just involved my wife in it, right? So now there are two-person, me and my wife, right? So what is happening here? So you can say there is one routing algo here, right? So now request is coming to this and it is redirecting to me, either me or to my wife, whosoever is available, right? Now, now look what I'm now able to cater more just double number of customers now. But the problem comes now. The problem is basically, so whatever the entry that I have, right, my wife doesn't have those entries, right? And whatever the entries my wife have, I don't have any entries, right? So there is no synchronization between them. So in future, if let's suppose if X called to me and with X called to me and he just noted down something to me, right? And next day, it might be happen the routing algorithm just route it to my wife. So and my wife is having not having that information, right? So that is a bad customer experience, right? So what I think, so now I have come up with, you can say, new solution for that. What I have done here, I say that we decided, my wife, that whenever any customer calls me, right, don't put that phone until unless that information is communicated to other partner. For example, if X calls me and just give some information to me, let's to save my birth date or flight number. So I will just call my wife first and note down that information here, right? Now you can see that there is some latency here, right? But the my information is consistent, right? Now X can call anytime and he is able to get the information. So problem solved, right? But next day, one more problems occur. For example, what happened is my wife becomes sick, right? She is sick now. So she is not available to take the entries now. Now, what can be the solution? Means there is two problems now. Either I can become unavailable for whole day till the time my wife is sick, because whatever the information I am writing, I'm letting it down to my wife, right? Or I can just play the trick because I need to serve the customer, right? So what I'll do, I will say my tell my wife. So whenever you come back to office, right, you just first of all take the differences between our two diaries, right, and note down those entries first, then start taking the new calls, right. So this way I can be available for that duration of time when my wife is not well, right. So I can be available, right, in that case. Now it might be possible, right, there is fight between me and my wife, right, we are not talking to each other. Then again the problem arises, right, whatever the information I have, I'm not able to communicate to my wife, and my wife is not taking that information. So somehow there is a lack of inconsistency, right? We both are available, but you can see there is consistency is not there, right? So this is if you look at whole scenario here, so this is what is known as cap theorem, right? So if we just summarizes our just look back our whole example, what we have seen here, right? So we can categorize the whole thing in three circles, right? So let's suppose this is consistency, so I'm denoting it with C, and let's suppose this is availability, I'm denoting it with A, and this is partition, right? So this area we can say that this is CP, and this is something AP, right? So so what does it means, right? So let's suppose uh, let's talk about what is AP. So if AP means availability and partition, right? So what does this mean? So basically, you can just think of the example uh, you can take in real time is MongoDB, right? And so you know that MongoDB have you can say master slave architecture, right? So there is one of them is master, and which is communicating all the information to all the slaves out there, right? So it is available all the time because basically we are uh, communicating information to all of them, right? But what if my master goes down, right? So there is the time that I will be not available. But if you see in whole this scenario, let's suppose this is a master that is communicating the information to all of the slaves. So there will be some latency in between, right? So it might be possible that I'm not delivering the consistency here, right? It might be possible that I'm not delivering the consistency because requests can come to this slave for the timing, right? Because write is handled by the master. So in this, if we use the MongoDB, it might be possible that my data is not consistent, right? But let's take an example of CP, right? So in CP, what I can do, I can have lots of Apache servers, and you can say they all are having their own data, right? So what it is having, you can say, ensuring that all the data is consistent, like whichever the request I'm getting, but it might be possible that one of the server goes down at any point of time, right? So this will not become available for the timing, right? Because it might be possible that you can have one server in every region and you have to notate it. And each server is maintaining its own database and is responsible for it. But it might be possible that in real time that server goes down. So your data will be not available for the timing, right? So then there is a CP. Means you are consistent, you are partitioned because you have divided your geo based on your server based on geo, right? But you are not available all the time. There might be some scenario that you are not available, right? So this is what cap theorem is. So cap theorem says that at any point of time in a distributed computing, you will have either consistency or availability, right? Or you can have, uh, sorry, at any point of time, you can have either availability or partition, or another is either you have consistency and partition. So this is the two things, right? But yeah, nowadays things are getting changed, right? We can make these availability and partition to make eventually consistent means with the MongoDB architecture that we have talked about, means we are available, we are partition, but somehow there might be some time in between which our latency, you can say, in which is taken by our master to copy all the data from master to the slave. So at the end, my data will be eventually consistent. So this is all about cap theorem. See you in the next video.